Again, please open your camera. Message me if you cannot open your camera for some reasons. Thank you. Alright, so regarding dun sa, di ba yung iba nasa uli ko na dun sa Gen Math by the way, yung mga task niyo. Links lang kasi yung ano, nailagay niyo dun sa iba, di ba? Hindi ba kayo sinabihan ng advisor niyo na ano? If ever maraming pages yung output, for example, you just have to attach the first page. Okay, pag ano, kung kaya niyo pang ihabol niyo yung ano, wag yung link, please. Ahmad, Badron?
Ay, po sir.
Yes, sa e-portfolio mo, sa e-portfolio, lahat links yung naka-attach doon.
Opo.
Pa-edit nun. Ha?
Sige po sir.
Okay. Kasi hindi natin makikita yung mga output doon, puro lang link. And then yung mga nagpasa sa akin, hindi ko pa na-check na link lang yung pinasa, pa-edit na lang please. Para ma-finalize ko yung grades nyo. Yung mga, kasi tawag ito, kapag, di ba sa aking subject is ilang pages na naman yun, di ba? So, kahit first page lang yung i-picturean nyo, i-update nyo lang, sabihan nyo ako na ano, na-edit nyo na. Mag-private comment kayo doon ulit, hanggang mamayang gabi, edit nyo, para ma-finalize ko na yung output nyo. So, yung score nyo, pwede pa magbago yung score nyo na, yung binigay ko na score, pwede pa yung magbago. Okay, basta baguhin nyo yung comment ko doon. Nandiyan si Wilson? Wilson, ano ba yung comment ko? Walang attachment, Wilson, yung output mo. Sa GenMath, pa-check. Sino ba yun? Okay. Gwyneth, the other attachments, wala doon sa task mo, Gwyneth? Yeah,
Sir,
kailangan
ano po yung, ano sinasabi niyo, sir?
Yung sa e-portfolio mo, may some of the exercises are missing, walang attachment. Nung inopen ko, walang attachment.
Sa portfolio po, lahat
Yep.
lahat po walang laman yung portfolio po.
Some of the sa exercises sa subject ko, walang attachment yung ibang exercises doon.
Sige, check ko po.
Double check.
Sige po.
And also, wag pag nag-post kayo doon na naka Google Drive, wag kayong mag-post na magre-request pa ako ng access. Kailangan accessible na anytime. Okay, kung maaari, naka-Google Docs ngayong ano, di ba? If ever nag-edit kayo, naka-Google Docs para makita ko yung progress nyo. Di ba? Sige lang, at least pagdating na second quarter, maayos nyo na yan. So, yung mga nagpasa na nabigyan ko na ng grades, na wala mga attachment, pabago, para mabago ko yung score nyo. Pag hindi nyo pa yan babaguhin, hindi ko na yan babaguhin yung score nyo. Mataas ako magbigay ng grades, guys. Kaya, i-comply nyo lang din. Yung mga hindi ko pa na-check, guys, pa-double check nyo yung output nyo. And then, kung wala na ba kayong kulang doon? Kasi pag i-check ko yan mamaya, tapos hindi na, what you call this one, hindi pa complete yung mga attachment. Baka may mga minus tayo doon. So anyways, okay, we'll continue discussing now. Mga pics lang naman. Yeah, picture lang naman. First page na picture. Yun na, huwag na kayo mag-attach. Title, I-print screen nyo yung may score doon sa Google Classroom nyo, tapos picture, isang picture lang, proceed to the next exercise. Ganun lang kadali. Alright. So let me share screen my PowerPoint here. All right, so last week, I think, during the World Teachers Day, Teacher Ken, right? She started discussing gases and the atmosphere. That was chapter 4. And she had an activity with you about a conversion of the different units of pressure. Meron tayong bar, torr, millimeter of mercury, Pascal. Okay, and then you had a short activity on that one, right? So I was observing at that time, and you did all well on converting one unit to another. Now this time we'll continue discussing on gas pressure. So we have here, can you see now my slide? Isang slide lang, hindi siya naka-ano. Tama? Give me a thumbs up kung one slide lang yung nakita nyo. Okay, thank you. So we have here pressure, which is equal to force over area. And when you can recall your Newton's law, second law of Newton, which is mass times acceleration. So by substituting there for the force equals mass times acceleration, then you can have mass times acceleration over area as your formula for your pressure. And you have there the different units for pressure also. I have posted this one in your classroom, right? So you can just also check there. Yung mga hindi magkokopya, you can check your Google Classroom. So here, we have your gas pressure, indicated here that it can be measured through a barometer. So if we have here different formula for pressure, depends on the given. Pressure can be solved when given mass and acceleration divided by area, which is equivalent to F over A also. Gravity there can be 9.8, and some books may use 9.81, or some books may use 10. So it can also be M times G, mgh over volume. Okay. The formula for our pressure can be mgh. Ano ba yung mgh natin? Yan yung formula ng potential, yung height natin, di ba? Potential energy, mgh. You can also divide that one by volume. And also, we can see here that mass times gravity times height over volume is just simply equal to density times gravity times height. Now, sir, sa GenChem din po. Yep. Kailangan din ng ano doon, picture. Kasi yung sa GenChem naman natin, mga exercises naman tayo, di ba? Wala naman tayong links masyado. Hindi naman mabibigat yung file natin. Hindi naman mga video yung pinagawa ko sa inyo. Yeah. Picture dapat. So, yung mga nag-submit ng link, pabago na lang po. Thank you. So here, density, bakit saan galing tong density? It's from here, mass over volume. Okay, density times gravity times height. Okay, that's another formula for pressure. All right, so next, we have here atmospheric pressure, for example. Okay, we want to calculate. Okay, by the way, guys, it doesn't mean that if you are given one formula, say for example, this one, pressure equals density times gravity times height, we do not stick to that formula. Okay, there are times that you need to derive another formula from here to solve for the unknown. It can be the unknown is height, the unknown is gravity, the unknown is density, or the pressure itself. Now, for this problem, calculate the length of a column of water supported by a pressure of 1 atmosphere. You're going to assume here that the density of water is equivalent to 998 kilogram per meter cube. So, since length yung unknown, manipulate the formula. Your formula for your height equivalent to your length of the column of water is equal to pressure over density times gravity. Now, your pressure here is given 1 atm. Now, you are going to apply your conversion here. Since yung unit ng density natin is in kilogram per meter cube, then convert atmosphere to kilogram meter per second square. Saan ba galing yung kilogram meter per second square? That is yung equivalent ng Pascal, yung force over area, di ba? Yung formula ng force over area, kilogram per meter per second square. Now here, 1 atmosphere is equivalent to 101 kilopascal. Okay, now your 101 kilopascal, when you convert that one to kilogram meter per second square, is just simply equivalent to 1.01 times 10 to the power of 5. Bakit times 10 to the power of 5? Kasi kilo means 1,000. So 101,000. When you convert that one to scientific notation, ito yung equivalent niya, 1.01 times 10 to the power of 5. Divided by the density, given yung density natin, which is 998 kilogram meter per cube. And then yung gravity natin, given yung value natin kanina, which is 9.81. Then solving this one, we get height equals 10.3 meters, or approximately equal to this value 33.8 feet. Okay, so that is just an example of how to solve problems involving conversion depending sa ano. All right. Next. Yeah. All right, next slide. Okay, now we move to kinetic molecular theory, or the KMT, before we discuss the different gas laws. Now, here in kinetic molecular theory, there are different postulates here that will help us describe the characteristics of gases. Now, here, first one, gases can be compressed, unlike the liquids and solids. Gases exerts pressure on whatever surrounds them because they are why they exert pressure on whatever surrounds them, because they are trying to escape from its container. Gases also expand into any available volume. It will occupy the container itself. They are completely miscible, and they are described in terms of T, P, V, and N. And this T stands for temperature, pressure, volume, and N stands for number of moles. Now, in this description for gases, this involved for the different gas laws later on. So for the kinetic molecular theory, a gas consists of tiny molecules in rapid random motion. Gas molecules are small compared to the distances between them, easily compressed, mixed completely with other gases, move randomly, small attractions or repulsions, and in ideal gas, they behave the same way. All right. So here we have here the kinetic molecular theory can be calculated, the kinetic energy, applying what you learned in your physics. Yung kinetic energy equals 1/2 mv squared. So when gas molecules collide, their speed and direction changes. So from this formula, you can compute its kinetic energy of a certain gas. 1/2 times mass times velocity squared. And then ano yung expected unit natin ng kinetic energy, guys? If mass is in kilogram, velocity is in meter per second, then this is square, di ba? Kilogram meter squared per second square. So what is the expected unit of our kinetic energy? From the word itself, energy. Ano yung unit ng energy natin, guys? Sa physics nyo. Sa group chat nga. Ano yung unit ng... It's not joules, yeah. Ayun, may nalilito nga. Do not be confused with the word... Ayan. do not be confused with the... Yeah, joules, tama. Do not be confused with the word unit and formula. When I say unit, yun, joules, meter per second. Kasi I've encountered a lot of students na naku-confuse dyan. Okay, so when gas molecules collide, their speed, all gas molecules are constantly moving. So we have here, average kinetic energy is proportional to its temperature in K means Kelvin. Okay, I hope you still remember how to convert Celsius to Kelvin, because In discussing gas laws, we will be converting Celsius to Kelvin. Okay. So here, we have here, based on the kinetic molecular theory and the different postulates, as shown here in the table, we can say that higher temperature, look at here the label of the table. Okay, higher temperature, look at there, diba, papunta dito, we have 1000 degrees Celsius, 25 for example. Higher temperature means higher speed. Okay, according to kinetic molecular theory, the postulates there, it supported that higher temperature equals higher speed. Now, for this case, if higher temperature equals higher speed, what can you say about lower masses? Pag lower mass yung kanyang gases, what can you say? Does it have higher speed or lower speed? Sige nga, sa group chat nga guys. My question is, for this case, higher temperature means higher speed. Now, what if we have lower masses for different gases? Lower yung kanyang mass. What can you say about its speed? Will it be higher or lower? What do you mean saying? Again, lower mass. I'm asking if kung lower yung mass natin, what can you say about its speed? Will it be higher or lower? Yes, correct. Higher speed. Okay? Lower mass equals higher speed. Siyempre, pag magaan, di ba? Mabilis yung mabilis yung kanyang rate of effusion. Now, talking about rate of effusion, ayan, lower mass equals higher speed. So, ano ba yung mass dito na sinasabi? Ito yung sinasabi na molecular mass. Okay? So, ibig sabihin, say for example, based on the table, we have here helium, yung naka-black. And then yung red is oxygen gas. Now, what's the molar mass for oxygen gas? Diba? Yung oxygen natin is 15.999. And then oxygen gas times 2. So that is 30, this one, 30 something. Diba? 32, for example. And then our helium here is 4. So, ibig sabihin, lower mass, higher speed. Okay? Diba? Tingnan mo dito. Yung oxygen gas is close to 500 lang yung kanyang molecular speed. Pero yung helium is more than 1,500. Okay? So, as you can see here in the table. Alright, yung sinasabi ko kanina, effusion. Okay. Now, before we discuss this term effusion, I know for sure you have encountered the word diffusion. Now, who can recall what does diffusion means? Okay, in your chemistry sa sa junior high school nyo, siguro nag-experiment kayo doon ng example ng diffusion of gases. Now, what does diffusion means? Ano ibig sabihin ng diffusion? Spreading out of substance. Yung mga nakakalimot na, yan, nasa tabi nyo lang si Google, control control N, yung tab, control N ba yan? Ibig sabihin ng dyan, ang sabi ni Google dyan sa diffusion. Yep. Okay, spreading of molecules widely, or yung from high concentration to low concentration, di ba? Nag-diffuse yung gases. Who can give me a practical example or an example that you have experienced most of the time wherein diffusion is observed? What about the AC? Kapag binuksan, okay, di pa naman malamig agad. And then, yung lamig niya is nagdi-diffuse. Okay? Aside from the AC, yung mga tawag nito, bilang isang binata kayo, mga binata at dalaga, ano yung mga ginagawa nyo na there's a presence of diffusion? Okay, mag-isip nga kayo ng ano, yung mga ginagawa niyo na ina-apply niyo sa katawan niyo, for example, na merong diffusion. Pagka-open ng baunan. Okay, so pag nag-open ng baunan, right, medyo nawala kayo. Ayan. So pagka-open ng baunan, ayun, naamoy na yung ano, from that certain area, sa isang corner, kumakain yung kaklase mo, pag inopen niya yung baunan, ayun, nag-diffuse yung odor, spreading of gas molecules. Yeah. Or, di ba, binata at dalaga, nagpapabango tayo, di ba? Para mapansin ni crush. O, di ba? So, what can you observe when you put some cologne or perfume? Di ba? Nag-spread din yung amoy. Okay? It diffuses. Now, let's go back to effusion. So, here, effusion is, parang madali lang ito, of gas through tiny holes into a vacuum. Okay? And the rate of effusion can be calculated since it is just directly proportional to 1 over the square root of its molar mass. Ang ibig sabihin ng M dyan is molar mass. Okay? So, kanina sa table natin, pinakita natin doon kanina na lower masses, higher speed. Now, to prove that one na yung lower masses have higher speed, now let's check here the rate of effusion for helium and nitrogen gas. So for helium, we have 4, yung kanyang approximately 4 yung kanyang molar mass. And for nitrogen gas, we have 28 approximately. Now it says nitrogen gas. Bakit? So 1 over, compare natin, ano yung molar mass ng molar mass ng nitrogen gas. Okay? That's 28 divided by the molar mass ng helium, which is 4. So 28 over 4, then you will get 28.7 times 4, diba? 2.6 times faster than the nitrogen gas. 1 over the square root of 7, which is 2 point something. So this is the rate of effusion of helium compared to nitrogen. A thumbs up. Okay, yeah, there you go. So here we move to the behavior of ideal gases. Now we'll start talking here the different gas laws. So any equation relating to volume, pressure, temperature, and N, yung N natin dito is yung number of moles. Okay, yun yung tinatawag natin na gas laws. So most gases at room temperature and pressure are considered to be ideal, meaning to say they follow a simple set of gas laws. Now, what are the different gas laws you can still remember when you were in your junior high? Ano yung mga gas laws na naalala nyo? Give me one din sa group chat. Yung mga gas laws na naalala nyo? Yep. Kay Boyle's. Yan. Common si Boyle. Sino pa? Yan, si Charles. Charles law. Diba? Marami yan. Alright, so we'll start with the common one, which is Boyle's law. Now, in solving for Boyle's law or Charles' law, there are factors that we need to hold constant. Okay? We need to hold constant. Say, for example, here, Boyle's law. For Boyle's law, volume varies inversely with pressure. Meaning to say, if you have higher volume, then the pressure is lower because they are inversely proportional with each other. So what values are we going to hold constant here? It must be the temperature and then the number of moles. So formula, since PV is constant here, so we can say that pressure 1, times volume 1 is equal to pressure 2 times volume 2. Now, I will just be giving you this formula, this base formula, meaning to say not all the time that I will give you the formula to whatever the unknown in the problem. Okay? So it's on your end na to derive a formula to solve for the unknown. Okay, say for example, for Boyle's law, the unknown is pressure 2 or P2. What will be your formula for your P2 then? Give me the formula for P2 in the group chat, please. If P2 yung unknown natin, ha? Okay, in the group chat, give me the formula for P2. All right, Clarence, that's correct. William Moore, Princess, MJ, Carol, that's correct. So P2 is simply equal to P1 V1 over V2. All right, that's correct. Now, how about if the unknown is volume 1 or V1? Volume 1 is unknown. Okay, volume 1 is unknown. P2 V2 divided by P1. Okay, there you go. So let's have an example on that one regarding Boyle's law. Say, for example, let me clear my drawing here. Okay. Say, for example, we have a gas that is trapped on a tube na meron siyang volume na 30 centimeter cube. Also guys, in problem solving, always be careful with your unit. Kasi pag nagbibigay ka ng problem solving tapos mali yung unit, automatic may -1 yun. And then let's just say for that certain volume of gas that is trapped in a tube, meron siyang, it is trapped in a tube with 760 millimeter of mercury. Okay. Now, if you are going to add mercury to this pressure, for example, from 760 millimeter of mercury, you are going to add 305 millimeter of mercury. Meaning to say, if this is your pressure 1, the new pressure or your pressure 2 will become 1065, for example. Okay, do not solve yet. May tanong pa ako. Okay. Here, from 760 to 1065, based on Boyle's law, it says there that volume varies inversely with pressure. So what will be the expected value of your volume? Will it be lower or higher than your original volume here? Okay, sa group chat mo na ang sagot, will it be higher or lower with V1? Yung expected mo na volume 2. Higher or lower? Okay? So the answer is lower, correct? Kasi varies inversely. Kasi kung makikita nyo dito, yung pressure 1 increases. So therefore, volume will decrease. Now solve for volume 2. Solve for volume 2. Careful with the unit, ha? Isama nyo palagi yung unit. Dalhin nyo palagi yung unit. Kasi pag hindi nyo nilagay ang unit, pwede kong lagyan niya ng iba't ibang unit yan. So magkakaiba na yung value pag kinonvert ko into another unit. Oops. Carol, double check. That's 30, 760, and 1065. Okay, yung mga nagsagot dyan, all correct yung sagot nyo? Kirk, careful with the unit. Yeah. Oops. Oops. Jam, careful with the unit. Mukhang mali yung exponent mo. So yung mga hindi ko sinabihan na yung mga nag-send dito, tama na yung sagot nyo. Yeah. So the answer is 21.4 centimeter cube. Kasi base sa given, volume yan, di ba? Wala namang volume na square lang yung exponent. That's cube. All right, that's correct. 21.4 centimeter cube. Thank you. All right. So there you go. 21.4 centimeter cube. All right. Next. Now here, we are relating volume to pressure, and yung constant natin dito are temperature and the number of moles. Now what if yung constant naman natin dito is pressure and number of moles. Kanina, temperature and number of moles. Here, pressure and number of moles. So we're talking about here Charles' law. Now for Charles' law, yung kaibahan niya sa Boyle's law, kanina, inversely proportional yung pressure sa volume. Here naman, since pressure is held constant, it's the volume that is proportional to temperature. And then careful, we're talking about here not just the temperature na yung naka-degree Celsius, but yung absolute temperature. When we say absolute temperature, we are going to convert Celsius to Kelvin. And the conversion value of Celsius to Kelvin is just, you will just add 273.15. Okay? 273.15. We include 0.15 there just to be more accurate instead of using just 273. So volume here is directly proportional to the absolute temperature. So we have here the formula V1 over T1 equals V2 over T2. All right. In the group chat, please, what if temperature 1 yung ano natin? Base sa formula, okay? Base sa formula, what is our formula if temperature 1 is unknown? Temperature 1 yung ano natin, ha? Ano yan, Vil? Hindi pa tapos. Okay. The formula is, ayan, temperature 2 times V1, T2 times V1 over V2. All right, that's correct. T2 V1 over V2. Okay. Yep, Bill? Okay, ayan na. Okay, yeah. So, yung mga sumagot, Wilson, that's also correct. Kung sino pa yung Ahmad, that's correct. Now, how about if T2 yung unknown? Adriel, that's correct. How about if T2 yung unknown? Okay, if T2 yung unknown, we have T1 V2 over V1. All right, that's correct. Okay. All right. So here, as what I've said a while ago, the absolute temperature scale, 0 Kelvin, guys, is what we considered as the absolute zero. So 0 Kelvin is equivalent to negative 273.15 Celsius. Magkaiba sila. Pero yung 0 degrees Celsius, 273.15 Kelvin. Now, when you write Kelvin, there's no need for you to write degrees. Okay, so it's considered na absolute. Okay? Now here, let's have an example for Charles' law. Okay, say for example, you want to calculate the new volume. You are going to calculate the new volume. I will not label V1, V2, T1, or T2, but just analyze the problem. Say for example, you want to calculate the new volume when 450 ml of gas is cooled from 60 degrees Celsius to 20 degrees Celsius. Okay? At constant pressure. So meaning to say, pag sinabi at constant pressure, then you can conclude that you are going to use Charles' law kasi constant yung pressure natin dito. Again, Say for example, you want to calculate the new volume of a gas that has an initial volume of 450 ml and is cooled from 60 degrees Celsius to 20 degrees Celsius. What will be your what do you call this one? New volume. So I did not give you a label kung saan dyan yung V1, V2, T1, or T2. So it's for you to decide now saan dyan ang V1, V2, T1, or T2. So basta yung unknown ko dyan is new volume. So you can say that yung old is yun yung 1, yung new is yun yung 2. So ano yung first na step dyan, guys? Since yung given natin is naka-degree Celsius, then we're talking about Charles' law. And in Charles' law, volume is directly proportional to the absolute temperature. Therefore, we are going to convert Celsius first to Kelvin. Yep, correct? Yeah, MJ, that's correct. May point pa yan, di ba? Hindi mo lang in-include. Ano yung kasunod niya na point? Yeah. Will, that's correct. Yeah, so i-round off mo sa whole number, MJ, kasi yung hindi mo naman pwede ma-round down yan, di ba? Kasi 0.9 na yan eh. Kasi naka-whole number din naman yung ano natin, given initial volume. Ahmad, double check please. Medyo sobrang laki ng sagot. How about the others? O, ito na lang yung last natin. I need more answers. Kirk, double check. Maybe you did not convert your temperature to Kelvin. Again, when you solve Charles' law, you have to convert Celsius to Kelvin first. Correct. Mikhail, correct. Princess, that's correct. I need more answers. This will be the last before I will dismiss. Yung mga hindi na pa-participate simula kanina, participate na. Siyempre, may record ako dito kung sino mga napaparticipate, di ba? Kasi naka-recording to. Again, please double check your answer. Maybe nagkabaliktad ka ng T1 or T2 mo. So again, yung old volume mo is 450 ml. You want to calculate the new volume since you cool down the Celsius to 20 degrees Celsius. Jam, medyo sobrang laki din Jam. Double check please. Carol, double check also. Again, that's correct now. Kirk, that's correct. Again, yung conversion natin from Celsius to Kelvin, you will just add 273.15. Rosette, that's correct. All right, so the answer is 395.97 or 396. 395.97 or 396. Again, yung ano natin dito is V2. So formula ng V2 natin dito is V1 T2 over T1. So saan ba dito alin dito ang V1, alin ang V2? So V1, ito yung 450 ml mo, yan yung V1. Kasi ano natin is V2. Ito yung temperature 1 natin, itong 60 degrees Celsius. Temperature 2 is 20 degrees Celsius. But before you substitute this one to the formula, you must convert first your Celsius to Kelvin. And you will get 395.97 or 396 ml. All right, so there you go, guys. That's it for today. And I see you all tomorrow. We'll continue discussing about gas laws tomorrow. So if you have time tomorrow in your independent study time, please study in advance the PowerPoint posted there in your classroom. All right, so thank you so much, guys, and I see you all tomorrow. So bye for now, guys.
Thank you, sir.
Bye, sir.
Bye, sir. Thank you po.
Thank you po.
You're welcome. Thank you, everyone.